Hi, today let's talk about how we're going to implement the list abstract data type using arrays in C. As we had already discussed, arrays are contiguous collection of data items that belong to the same type. Arrays are very useful because they offer a very fast index-based access to the elements it contains. Arrays have a disadvantage of not being dynamic, so once the size of an array has been defined either at compile time or specific memory has been assigned to it during runtime, it is very inefficient to change the size later on. Now let's try to see how the list abstract data type model maps onto the array data structure in C. As we had defined earlier, the list abstract data type model is a collection of tuples of the form t, I, where t is the element and I is an ordinal that is mapped to the element. The mapping of each and every element in list to an ordinal or index helps us order these elements. These tuples naturally map to array in a very convenient way because arrays have values which are similar to elements, and all of these values are indexed by integers which are similar to the index or ordinals defined in the abstract data type. So in this particular case, this array, which has elements 1, 2, 3, 4 and so on, indexed by a zero based index of 0, 1, 2, 3 and so on, can be represented as a collection of tuples 1, 0, 2, 1, 3, 2, 4, 3 and so on. Now let us try to see how I represent the model of the list abstract data type in terms of the primitive complex types in C. I define a type def struct which has two elements in it. The first element is the array, which will contain all the elements of the list, and the second one is a size, which will contain the number of elements contained in the container at any given point in time. Now the size is just optional. I'm just using it for convenience and for better readability of my code. There might be again better ways of implementing this, but this is the design that I chose. And max size is the size that we define at compile time, the maximum number of elements that this array can contain. The size is 0 for an empty list to start with, and it is updated whenever the array is modified by way of either inserting an element into the array or deleting element from the array. Coming to the set of operations that we are going to implement, picked up from the definition of the operations of the list abstract data type, we first have a size which will give us the number of elements contained in the list. First and last are pretty obvious. They give the first and last elements of the list. Insert and delete, put an element into the list and delete an element from the list at a given index. GetIndex gives us the index of a particular element. Get gives us the element given an index, and append just inserts an element at the end of the list. We'll try to implement all of these functions. I'll show you some of them. GetList is a helper function that I have to allocate memory to the structure that contains my array and the size. So you can represent this diagrammatically as follows. You have a pointer to the structure which has the size as one of the elements, and then we also have an array represented by the address of the initial element of the array. So the structure has a size and the initial address of the array, and all my functions accepts the address of the structure. Instead of having to copy the entire structure with the array, I just pass along the pointers address of the structure to all my functions. Initialize is a helper function that initializes size to 0 at the start of the life of the list, and print is another helper function that's useful in printing out the element of the list. Size is a very simple function. It just returns the size maintained in the structure. As I said, the size is always kept up to date whenever there's an insertion or deletion from the array, so it's okay if we just return the size from the structure. Get, which basically gives us the element of an index, is also pretty easy because we have good quick index based access in the array. We just return the element present in the array at the given index, and this index is a 0 based index, so the first element starts at index 0, and this is analogous to the function get element at index that we defined in the abstract data type of list. Insert does three major tasks. The first task is to validate the index. Index has to be in the range of 0 and the size of the list, and it also can't exceed the maximum size that the array has been allocated, in which case it just returns a 0. The next piece of code is probably the meat of the function. This code tries to vacate the slot into which we are going to insert the element, and this also leads to the elements to the right of the slot being right shifted, and this code basically starts from the rightmost element and copies all the subsequent elements in a right shift manner, and this shifting logic is probably the most involved part of the code. And then we insert the element at the slot that has been vacated by the right shift, and then increment the size to keep it in sync with the number of elements. Deletion is analogous to insertion. It also does an index range check, and then it tries to keep the value that is being deleted in a variable and tries to do a left shift of all the elements that are to the right of the index in which the deleted element was present. So this code just saves the value 5 which is being deleted and copies over the subsequent values present in the array one place to the left of each of those elements, which means that we have a new empty slot at the end of the array, which actually has a value, but as far as our logical structure is concerned, we won't care about it because the size is anyways decremented by 1, and we basically don't keep track of the last slot anymore. So those were the implementation details for the list in C using arrays. The code is available in GitHub, the link to which has been mentioned in the summary of the video. Let's meet in the next lecture with the implementation details of list using linked list in C. Thank you.